Hello viewers, today in this video I will explain you how we can calculate the magnetizing current of an induction motor. Whenever induction motor is in operation, the total current drawn by the motor is always composed of two components. First one is the active component, second is reactive or also called magnetizing component. Active current is always directly proportional to the useful output power delivered by the motor, while the magnetizing current is necessary to establish the magnetic flux or magnetic field inside motor. Without this magnetizing component or without establishing the magnetic flux inside motor, it's not possible to transform power. So magnetizing component is also of a great importance inside motor. Today I will consider a real nameplate of motor and will show you how we can calculate the magnetizing current. This is a motor. Let's suppose that this motor is being used at 400 volt system. So I will take the values mentioned against the 400 volt rating, which are 400 volt delta, 50 hertz frequency, 30 kilowatt power, 54.6 rated current and 0.84 power factor. So let's calculate the magnetizing component as well as the active component of the current for the same motor. I am writing it down again, the same nameplate values, so that it should remain visible throughout the calculations. .6 is the rated current of the motor. It implies that whenever motor is being delivering 30 kilowatt rated power, then the current will be 54.6 ampere at power factor of 0.84. Now to calculate the magnetizing component, the most basic thing, the first of all we need to know is the phase angle, which we can calculate from the power factor value given. As cos phi is given 0.84, from this value we can calculate the value of the phase angle, which is phi, and phi becomes equal to cos inverse of 0.84. Here it comes. (32.85 degree). Now to calculate the active component of the current, first we will calculate the active component. Active component, I will denote it by IA. A is representing the active. IA is equal to I multiply by cos of phi. I is the rated current here. So by putting the values, I rated current, which is given 54.6, multiply by 0.84. It will be equal to 45.86 ampere. So this is the value of the active component from the rated current of 54.6 ampere. The active component is only 45.86 ampere. Now to calculate the magnetizing component, Im, it's again equal to I multiplied by sine of phi. Phi we have already calculated. So by putting the values, I, which is again the rated current, 54.6 multiplied by sine of 32.85. It becomes 54.6 multiplied by 0.542, which comes to 29.59 ampere. So this is 29.59 ampere is the value of the magnetizing component. So we were given with the rated current 54.6 and we have decomposed it into two components, active and magnetic or magnetizing components. The rated current or total current is always the vector sum of these two components. And to calculate the magnitude of total current IT, T is for total, is equal to square root of I active component square plus I magnetizing component square whole square root. So let's put the value in IA and IM is equal to square root IA, which is 45.86 square, plus IM, which is 29.59 square. Here it comes 54.577, or we can say that this is 54.6 ampere. Here we can see that it's exactly the same value that was given as a rated current on the motor nameplate. These two values. So the rated current we have decomposed into two components again by composed into single component, and we have seen that it comes the same value. I hope that this video will give you a very clear concept to calculate the magnetizing active and reactive components. If you like the video, kindly like, share and subscribe. Thanks for watching. See you in next video soon.